All right, so let's talk about how to prove the quadratic formula. Earlier on, we learned in our previous lesson how to solve quadratic equations using factorization, right?
Yes.
But sometimes some questions are such that you can't get values or you can't get values that would help you factorize. So we have to come up with another method that would help us to do our work. So we have the quadratic formula. I'm sure we've come across it before. It's x is equal to minus b plus or minus root of b squared minus 4ac all over 2a. X equal to minus b plus or minus root of b squared minus 4ac all over 2a. And how do we prove this? We prove it from the completion of square. We all know that quadratic equations are written in the form ax squared plus bx plus c equals 0. So this is a typical quadratic equation with this element as your coefficients. And then you could see from what we have here that we are using the coefficients in this quadratic formula. So let's see how this became this. Is that okay? So it's from the concept of completion of squares. Therefore, we'll complete the square to arrive at this place. Let's say ax squared plus bx plus c. And as we know, if we are completing the square, we make sure that we have our x squared term having a coefficient of just 1. So what do I do to achieve that? Sure, I can divide through by a. That would be over a is equal to 0 over a. So I'll have x squared plus b over a x plus c over a is equal to 0. And I would want to send the constant term to this side. That would give me something like this. Okay, let me use this side. I'll have x squared plus b over ax is equal to minus c all over a. And if I'm completing the square, what do I introduce to complete the square at this side? That would be half the, exactly. So that's half the square of the x term. So I'll have b over 2a all squared. And I also add the same thing, b over 2a all squared. So at this side, I would have to change it into the bracket form or the vectors form. And that would be what? X plus, yeah, b over 2a all squared minus c over a plus, yeah, Amanda, all over. All right, so in other words, when this square becomes 4a squared. And when I look at this side, how do I make these two to be like fractions so that I can add them easily? I'll multiply this one by what? I want to make them like fractions. So multiply here with, so times 4a times 4a. At the end of the day, I'm going to have minus 4ac all over 4a squared plus b squared over 4a squared. It's equal to x plus b over 2a all squared. So here I would have something like this. LCM to be 4a squared. It will be b squared minus 4ac equals to x plus b over 2a all squared. So continuing that, I would have, find the square root of both sides. I'll have x plus b over 2a is equal to plus or minus should be introduced here, root of b squared minus 4ac all over, no, still going to be this, 4a squared. All right. So finally, we would have x plus b over 2a is equal to plus or minus b squared minus 4ac all over 2a. So it means x will be equal to minus b over 2a plus or minus root of b squared minus 4ac all over 2a. We could see some like terms here and simplify this side. Would have all over 2a minus b plus or minus root of b squared minus 4ac. So simply, this is how we get this. And we'll be solving some examples to see how this equation works. All right.